In this statistics video, we are going to get an introduction to percentiles, and also box and whisker plots. Now first of all, let's define what a percentile is. A percentile is a measure indicating the percentage value below where a group of observations fall. Now it's important to understand that we are going to be using percentile and also the word percentage. These have different connotations, but have some linkage as well. So let's give you a quick example of what I could be talking about here. So if you have had a child born, you're going to get a lot of percentiles. A percentile measures where your child is in comparison to all of the other children that are born within a relatively quick period of time. Because as society and social changes, develop, it's possible that the height and weight of your child could be different and very time dependent, because we have seen over the course of decades of data that children are born bigger and heavier than they used to be. So let's just kind of drill down into a more specific example. Let's say that your child was born and they said, wow, you have a very healthy child. It is in the 65th percentile. Now, what's interesting about percentiles is that they are usually given with a TH or an ST or some kind of ending to them rather than a percentage. That way you can understand that we're talking about a percentile. Now, if they said that your child was in the 65th percentile, that means that 65% of the children born weighed as much or less than your child. And 35%, the complement, are actually at your weight or higher. Now, we're really not concerned about the exact moment here for this example, but it gives you the idea that you would have 35% above and 65% below. So this is where you can see that the idea of a percentile is related to the percentage, but it means a categorically specific thing. So if they said to you, hey, you're in the 80th percentile for your height or weight or intelligence or your ability to run a certain distance in a certain time, that means you're in the top 20% because there's only 20% higher than you and that there's 80% below you. So that's kind of a neat little example to write down too. If you were in the, let's just do a new one here. If you were in the 90th percentile, then you would be in the top 10% because only 10% would be above you, and there's 90% below. So there's lots of ways to kind of talk about these percentiles and percentages, but we're going to really hit on the 5 percentiles that come up the most often and also get the most use in statistics. Now, the biggest and most important percentile is the median, also denoted by the capital letter M, because this is the 50th percentile. And that is another way of saying the halfway. You're in the middle, 50% higher, 50% lower. And one of the cool things about this median is that the median is resistant to what's happening if there are outliers. It doesn't know. It knows it's in the middle. Half of the data points are above it and half the data points are below it. Now, just giving the median is a pretty good measure of center. It's a pretty good way to say, well, half the class gets a B, and that means half the class gets a B or higher and half the class gets below a B. If you were told that the median of this class is a B, you'd feel pretty good. So let's talk about important quartiles, and because we sometimes want to just get into more detail than just the median. So what we have for the important quartiles is we have something called the 5-number summary. These 5 numbers, the minimum, the maximum, and the median, are 3 very important numbers out of the 5. There's also the Q1 and the Q3. Now, the Q1 and the Q3, the Q stands for quartile. And if you are thinking about the word quartile, you might think about quarter, right? Well, that's good because quartile means 25%. So this means that the minimum is at the very smallest, lowest part. It's the 0th percentile, which means that there are no data points below the minimum and 100% of the data points are above it. Where the maximum is at the 100th percentile. It's there's nobody higher than the maximum, and there's nobody lower, or sorry, everybody is lower than the maximum score. In general, obviously, if we have modal data, all of this can be thrown into disarray. But just in general speaking, it's easy to think that the median is the 50th percentile, and Q1 is called the first quartile, and that's the 25th percentile. And the Q3 is the 75th percentile. So 75% is below the Q3 and 25% is above it. Or another way to put it is 1 out of 4 is higher than this score, and 3 out of 4 are lower than this score. And in this case, you'd have 3 out of 4 is higher than this score, and 1 out of 4 is lower than this score. So it goes to say that the 5-number summary will give us a really cool descriptive statistics display of something that we haven't seen before or seen as well. And that's the V word known as variation. So let's take a look at this example. I've got 3 classes on your worksheet here, and this is an entrance exam for students going into 9th grade from 8th grade. Now this is a 20-question test over 9th grade or 8th grade math, and this is how many points the students got correct. So what I'm going to do is first of all identify the min and max, which is easy since the numbers are in order. So this is my minimum. Here's my maximum. Now the big thing is I'm going to try to find the median. And the median is really easy if you have an odd number of data points. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So here's my median at 11. Median. And it's my median because it is literally the middle person in this list. So there are 4 above and 4 below. And now we have to find the Q1 and the Q3. And if we think logically, if I cut 50% in half, I get 25%. But here's where things get a little tricky. If you have literally chopped up the median as one of these people, then the Q1 is halfway between these 4 data points. And the number between 6 and 8 is 7. This is our Q1. This is the data point that represents the 25th percentile. Now if we go up here and we don't count the 11 since it was crossed through, the middle of these 4 points is here. Now, if you're kind of figuring out like, oh man, what is this Q3? It's between the 15 and 18, and to find the medians, like we did in the video where we had to find medians for the relative frequency polygon, we add these up and divide by 2. And this would give us an answer of 16.5. So the 16.5 is equal to the Q3. Now, I should probably say that the one that I made with my pen here, these should be subscripts. So first quartile, third quartile, the subscript, the little number in the bottom corner, represents which quartile it is. So here we have our 5-number summary. We have 5, 7, 11, 16.5, and 20. Now to make our box and whisker plot, we're going to take the minimum and maximum and make those the whiskers. So I have a whisker at 20 and a whisker at 5. Now I'm going to find my median and make a line at the 11. So there's my vertical, a line at 11. And I'm going to make a line at 7 and a line at 16.5. I take the 3 lines and make a rectangle out of that, which makes the box. And then the whiskers are the little strands that go from the box to the bottom 25% and the upper 25%. So there's a lot to see here in just this one picture. The distance between Q1 and Q3 is 50%. So that means the box is equal to 50% of the data. Notice I use the percent symbol and not the percentile symbol. Half of the data is inside the rectangle, and 25% of the data is outside here, and 25% of the data is outside here, for a total of 100%. You'll notice that the 5-number summary is symmetric on the data set, but it is not symmetric on the number line. Our data does not match symmetry, and it won't match symmetry most of the time. I mean, it's a little bit symmetrical here, but definitely I would not call it as our role model of symmetry. So let's do another 5-number summary. Let's find the minimum and maximum. Pretty easy to do, 2 and 19, since I put all the numbers in order for you. Now what we'll do is find the middle. Now what's tough about this piece of data is that I have an even data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. With 12 data pieces, the median is between the 6th and 7th data point. So here is our median at 10.5. That is the number between 10 and 11. So now what I do to find the Q1 and the Q3 is I'm going to go to the left of the line and find the number in the middle. Now you see we did not cross off the 10. Up above we crossed off the 11, but here we did not cross off the 10. We're going to use this data point. We're going to say, okay, 10 is part of my data set here. 1, 2, 3, 4, 5, 6. What's the number in the middle of 6 data pieces? It would be between the 3rd and 4th. Notice the symmetry here. Now the number between 9 and 9 is 9. Not 9.5, that's the number between 9 and 10. The number between 9 and 9 is 9, and that is the Q1. First quartile. Now I want you to try to find the number that's in the middle here for our Q3. You may want to pause the video, try to find it, and then unpause the video and see where it is. The correct location is between the 13 and the 15, again giving me the balance on either side, and this Q3 is going to be 14, because that's the number between 13 and 15. You also could have added the 2 numbers and divided by 2. You could see that would be 14. And 9 plus 9 divided by 2 is 9. So finding the medians is as easy as using this formula here in the upper right-hand corner of my notes. Okay, so let us put down the minimum. Let us put down the maximum. And now a line for the median, a line for the Q3. Whoops, I put a 1 there. My bad. And then a line for the Q1, and here we go. Here's our beautiful box and whisker plot. Again, half of the data is inside this rectangle, and the other half is outside the rectangle. So if I was to compare these two classes, I would say that the middle 50% of this class is actually pretty close together compared to the middle 50% of this class. Now, my whiskers are longer, especially here, to say that, my extremes are more extreme. Now, if you can see the actual data, you can see that that whisker is long because of that 1, 2 value. But data is data, and this description of variation is valid. So let's look at the final example on this page, and we're going to let class number 2 still show to do some comparisons, because that's the power of this descriptive statistics, is to show the comparisons between these two. Okay, so here we go. Minimum 4, maximum 10. Okay, so let's count the data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So find the median. You may want to pause the video and then unpause when you think you've found the median. The median in this case is 5.5, because that splits the data into 2 equal pieces. Okay, now find the first quartile. Again, pause the video. Unpause when ready. Okay, so if you were to find the Q1, you include these 5 numbers. Notice we did not cross off this 5, so we include the 5 numbers. So this 4 is the first quartile. And now do the same thing for the third quartile. Pause the video. See if you can get the third quartile correct. Okay, you've unpaused. So we have 5 numbers, Q3, at the 7 mark. So let's put our dot at 4, put our dot at 10. We've got a median at 5.5. We got a Q3 at 7. Now watch what happens here. Our Q1 just also happens to be at that 4. And here we go. There's our box and whisker plot, but you say, hey, there's no whisker, and you're correct. The bottom 25% of the data is literally here, but it's actually on the same space as the Q1 because of the copied data points. They're the similar scores. So how would you compare class number 2 and class number 3? Well, class number 3 definitely has a smaller box, which means that the middle 50% of the students are really close together. So similar in terms of ability. Now, there's a small whisker on this end. I mean, it didn't stretch all the way up to these high scores, but you have this little stretch right here. And so the whiskers are smaller, the box is smaller. So this all boils down to a question I couldn't fit on this page, but it's on the next page. It says, on the previous page, which class would be the most challenging to teach? Which one would be the easiest? What is your main reason for your decision? So again, let's kind of go over the context of these 3 graphs. The context of these 3 graphs is that these were entry tests for 9th graders who came out after the summer and took a pretest on their first week of class in their 9th grade year over their 8th grade material. So a 20 is a perfect score. A 1 is a low score. Again, we have people did earn points, but you have 3 different pictures. So which one would be the easiest grade? Okay, so which would be the easiest to teach? Which would be the hardest to teach? Well, what you might be thinking is you might be thinking class number 3 would be the hardest to teach because they had the lowest scores. But actually, they'd be the easiest to teach because they have less variation. That's what's cool about class number 3. It has the smallest amount of variation. How cool is that, right? Now, you would have to make a pretty good argument, but both would be pretty valid, that classes 1 and 2 would be hard to teach. I think that's a good argument to make. Would 1 be harder than 2 or 2 be harder than 1? I mean, really, it kind of depends on your argument. I would lean a little bit towards the hardest class to teach would be number 1. And the reason why is because class number 1 has not only the widest box, which means that the middle 50% is pretty spread out, but also the whiskers are, not insignificant. And class number 2, the whiskers are very significant, but the box is a little tighter. So I'd say class number 1 slightly gets the edge for the hardest to teach because of its wide distribution of the inner quartile range, or the distance between Q1 and Q3. And the winner for easiest class to teach, despite the fact that they are lower scores, the smaller box and whisker plot indicate that if you come and plan for that ability level, they will be able to achieve that level. So, here's my final answer here. Which would be the easiest? Well, that's pretty straightforward. Class number 3. Which class would be the most challenging to teach? That is not so easy to see. And if you voted for class number 2, and I just want to make that look a little nicer there. Okay, so if you said class number 2, I wouldn't mark that wrong. But I think class number 1 slightly gets the edge. And the main reason for your decision is this word variation. And the variation explains how spread out the data is. And your biggest challenge in teaching, or really just kind of doing anything, is if you have a lot of variation. And that kind of goes along with any kind of job. If you're trying to do a job that has a lot of variation, it's going to be more difficult. If you have a job that has very little amount of variation, it's going to be very easy. The difference between working at a fast food restaurant, where there's very little variation for food allowed, and basically the parameters of how it's created is very regimented, versus being the head chef of a fine restaurant where you have lots of variation over your cooking station, and you have to be a wonderful machine to produce the same amount of wonderful food each night. So that's the power of box and whisker plots. Box and whisker plots, awesomeness for getting beautiful descriptive statistics of variation. Now, one of the cool things you can do when you have all the data and you know your 5-number summary is you can calculate a statistical outlier. It is very important to know that sometimes data can appear to be an outlier, but they're actually not outliers. So what we're going to do is we're going to talk about the 7 steps to find an outlier, and then we're actually going to use the data to actually see if outliers actually existed in this class. Okay, so in this 8-step process, the first step is step 0. And it's step 0 because you've got to make sure that you've put your numbers in order. Now, after you put your numbers in order, you're going to find M, which is another way of saying you're going to find the median. Now, we're actually not going to use this median in the actual process of finding the outlier, but we need to find the median so we can get our Q1, and we can also get our Q3. Now, once we found our Q1 and Q3, we're going to find the IQR. Now, the IQR is an abbreviation for the inner quartile range. The inner quartile range. And the inner quartile range is going to be taking your Q3 minus your Q1. Think about the inner quartile range like finding the range of a data set. The range of the data set is maximum minus minimum, and for the inner quartile range, it's Q3 minus Q1. Now, step 5 is a little bizarre because you're going to do something and it's not going to make quite sense why you do it. In step 5, you're going to take whatever your IQR is and multiply 1.5 times the IQR. Now, I might not use the time symbol, I might use the parentheses. But in statistics, we've found that if you take the distance of the Q1 and the Q3, which is your middle 50% of the data, and multiply it by 1.5, that distance away from the Q1 and the Q3 to the left and to the right, respectively, will show you your lower bound and your upper bound for an outlier. So, this last step is really kind of clutch here. Because what we're going to do is we're going to take that 1.5 multiplied by the IQR, and we're going to take that value and subtract it away from Q1. Then we're going to take, for step 7, our Q3 and add our 1.5 times our IQR. Now, when we do this, this will give us, to the right here, our upper bound. Anything higher than this red number will be considered an outlier. And on the side of the green here, anything left of the green number or lower than the green number will also be considered an outlier. So let me scroll down and keep referring back to steps 0 through 7 as we look to see if any of the data from class, the second class from this previous side, had an outlier. Now, what do you think about the 19? What's your guess on the 19? Do you think 19 is an outlier? Is it so far away from the rest of the numbers that it could be considered an outlier? Maybe you want to take a look at the box and whisker plot and see what you think. How about the 2? Do you consider 2 to be an outlier? Is it close enough to the group that you can consider it low but not an outlier? Or is it too far away and therefore maybe we shouldn't include it with the data for the variation? Well, let's actually do all of the steps. Step 0 was to put the numbers in order. Check, all the numbers are in order. Okay, step 2 is to find the median. The median is between the 10 and 11. I'm going to go through this kind of quickly since we did this problem on the previous page. Okay, now that we found our median, which is between the 10 and 11, we're going to find our Q1, which is going to be halfway between here and 10. Now we include the 10 when we look at these 6 numbers, so our Q1 is going to be 9. So Q1 is equal to 9. Then we look here, and we see these 6 numbers, and we find our Q3, and our Q3 is equal to the number that's the median of 13 and 15, which in fact is 14. Okay, so then we're going to find our IQR, and our interquartile range is going to be our Q3 minus Q1. And in this case, our Q3 was 14, and our Q1 was 9. 14 minus 9 is 5. Then we take our 1.5 and multiply, I can use parentheses or the time symbol here, multiply by the IQR, which is equal to 1.5 times 5, which gives me 7.5. Now I'm going to change colors here. I am now going to take that 7.5 and I am going to subtract it from the Q1. So 9 minus 7.5. 9 minus 7.5 is equal to 1.5. Now, how do I know if there's an outlier or not? Well, what I'm going to see is I'm going to see if there's any numbers lower than 1.5 here on my data. And it looks like there isn't. So since 1.5 is less than 2, so our smallest data point is actually bigger than this lower bound, we have no lower outlier. I know what you were thinking. You were thinking that the 2 was an outlier. Well, it's not actually. It would have to be a 1. So if this person got 1 point instead of 2 points, that would then be an outlier. The outliers are determined by how wide this distance is between the Q1 and the Q3. This distance between the Q1 and the Q3 is a gap of 5. So if we take that distance of 5 between 9 and 14 and multiply it by 1.5, we get a distance of 7.5 away from either of these. So we're going to go 7.5 away from the 14, and we're going to go 7.5 away from the 9. Now let's find out what happens here. I'm going to take my 14 and add that 7.5, which means that my 1.5 times IQR is added to Q3, which is then going to be equal to 21.5. Now, do you see any numbers up here greater than 21.5? We don't. So instead of me being specific about a data value, I can just say since there are no numbers above 21.5, no upper outlier. O-U-T-L-I-E-R. And that's how we do an outlier check. So if this 19 was maybe a 22, which would have been kind of weird since this is only a 20-question quiz, but if it was a 22, then that 19 would definitely be an outlier. Well, thank you for watching this video. The next video is going to cover finding percentiles from a table.